You're a good experiment. So we all have done an experiment where they do not take notes, and it didn't work very well. So now we know you have to take notes. Obviously, as you get older, it's up to you completely. Nobody's keeping track when you all go to college. If you choose not to show up to class, nobody cares. And yeah, some people are looking very excited by that. However, if you end up failing your classes, you get kicked out. So, while nobody might care that you show up every day and that you learn the material, if you don't learn it, nobody's going to be there to say, hey, where were you? And why aren't you doing your stuff? You'll just get a letter, or your parents will get a letter in the mail that says, this person, your student is on academic probation, and if they don't get it together, they will be kicked out of the semester. I know that's, well, yes, good question. That was not because of me. I actually, so, it was not a friend either. No. Or boyfriend. No. My first employer, so I worked as an engineer before I was a teacher. It's my teacher. My first employer had a daughter who was going to Stanford, I think, and she was like flunking some of her classes, so he came in and was all irate and was just complaining to us. So, anyway, all right, so here we go. She got it together. You'll all be very happy to know. She graduated. All right, so here we go. First example. So you guys are, the reason I wanted to do the experiment with this is because this stuff is going to take longer to write down than it is to actually learn and understand it, okay? So, but that's okay. You guys can do what you want to do. All right, what we want to do here is we want to see whether the 3i and 0 plus the square root of -9 are equivalent to one another, and if they are, we want to give a reason why. If they aren't, we want to give a reason why. So, 3i, there's not really much you can do to simplify that. However, what is the square root of -9? Written with an, it's 3i, and 0 plus 3i is, so they are equivalent, yes? Okay, this is a good enough reason, so you can just circle that. Okay, questions? See what I'm saying? It's easy enough to where you don't... Yeah, I'll stop talking. There are a lot. I'm not going to lie. There are a lot. We'll leave it at that. Okay, on the left, again, not much we can do to simplify that. However, on the right, what can I do with the square root of -4 to simplify it? What is square root of -4 in terms of I? It's 2i. I times 2i. And I times 2i is what? Good. 2i squared. 2i squared. Okay. What is I squared equivalent to? -1. Still put my question mark here. So 3 plus 2 times -1, that's the same thing as 3 minus 2, right? Okay. So those are not equivalent. And again, your work that you show, that's a good enough reason as to. Questions? No. We're back to our other book. Yeah.
Are all the problems like this?
No. The rest of them are like the next 3 pages of notes. Okay, here we go. Shh. But some of them are super easy. Okay. 2i plus 7 plus 3i. Combine like i's. So, Lydia. Go ahead. Say, I'm sorry, what? Yes. You'd think. Yeah.
Okay, Lydia, imagine if we all came into class and we're all sitting down writing notes, and this boy goes up there and says, it's just like variables. Do your homework. What are you going to react?
Okay, here's the deal. I will say this inevitably, yes. We're not going to go there. Stacy, when I combine like terms, what is it? Good, 7 plus 5i. Everybody give it up for Stacy. Next one. What do I get when I combine the next ones? Lydia. This better be a solution. No, they're adding. Combine, and this is why we are going through the notes. What? 2i plus 0, which is just 2i. Excellent. Okay, next one. So this one we have to make sure that we distribute that negative. So 3 plus 8i minus 3 minus 5i. And now if we combine like terms, somebody tell me what it equals. Haley.
It equals 3i.
Just 3i. Everybody give it up for Haley. Next, negative 9 plus 5i minus I plus 7. Again, if we're distributing, so we can go through at warp speed on some of them. Akashni?
Negative 16, right?
Negative 9 plus 7.
Oh, it's a positive, so it's negative 2
Good.
plus
4i. Excellent. Give it up for Akashni. So even though your homework looks long, you can see the level of difficulty of the problems. Okay, additive inverse.
Our homework is so long.
Okay, here we go. The additive inverse. Everybody zip it. Shh. Zip it. Additive inverse is if you were to add something to 3 minus 7i, we're looking for the thing that we add to 3 minus 7i to get 0. Ashley R.
Negative 3 plus 7i.
Cool, everybody give it up for Ashley R. Nicely done. So basically you're switching the signs of them. Next one, Lydia. Excellent, everybody give it up for Lydia. Okay. Next, multiplying. Yes, it is still just like variables.
Do you really need to write it down?
Yeah, I wasn't here.
Okay, shh. All right, let's not argue. I will pause. We're going, yeah. Lydia. Okay, shh. We are back on notes. Everybody zip it. What? Good, right, good. So we are foiling this out, or box if you prefer that. So if Mr. Russo was telling me that his students were complaining about the weather because it was sunny outside.
So cool.
I don't either. It's sun. Sun is nice. It's happy.
Wait, they're mad because it was sunny outside?
Because it's sunny outside, yes. All right, so let's FOIL this out. 2 times 2 is 4. 2 times negative I is negative 2i plus 6i minus I squared. All right, now what? Okay, so negative 2i plus 6i is 4i. I squared is what again? Negative 1. 4 minus negative 1 is? 5. 4. Wait, what? 5. 5 plus 4i. Okay, good. Question, Marcy? Go ahead.
So when we FOILed out 3i times negative I, where did the 3 go? I don't understand why it's negative I.
Oops, negative. Oh, good. I'm glad you caught that. If we had mole bucks, yes. So what does this change to instead? 4 plus 3 is 7. Good. Thank you for that. Okay. Next one. 0 plus 5i times 4 minus 2i. How many people agree that 0 plus 5i is the same thing as just 5i? Good. Okay. So that makes it easier because why? We just distribute. Shh. When we distribute, we get what? 10i squared, which comes out to good. 20i plus 10. At the end of that. How we doing on questions? Okay, here we go. Conjugate. The conjugate is we've done before. The conjugate. All right, so somebody tell me what the conjugate is, since you all are laughing at this problem. Or maybe you're laughing at me. I don't know. It doesn't really matter. But so, what is the conjugate? You guys tell me. Marcy.
Is that when you change the signs of the first one? Or
Close.
it's like the opposite of it.
It's the opposite in some way. In what way is it the opposite?
So would it be like 6 minus 3i?
The good. Okay, so 6 minus 3i. Everybody give it up for Marcy. Okay. Next, negative 9 minus 5i. Kendra? Negative 9 plus 5i. 5i. Good. Everybody give it up for Kendra. Next one. Jared.
Okay, this is the one that I think we all kind of missed, was the conjugate thing. And why do we only change the one with the variable?
Okay, that's a good analogy.
What?
In French.
Verbs.
I was.
We're not in French.
Okay, so they're talking about French and conjugate
Yeah,
verbs.
I don't know
Okay,
why.
so, all right. So here's the logical reason. Everybody exhibit. Fourth period is a very spirited group of kids. Okay, so here's the reason. So conjugate, you are changing the sign of whichever one has the radical. Okay, stop talking. Stop talking. Because what happens is, fully simplified when we're dealing with radicals means you can't have a radical in the denominator, so finding the conjugate helps us in the process of getting rid of the radicals in the denominator. So, and we're about to do one of those.
It's like when you use FOIL, once you get the negative one, it all cancels out.
Exactly. Yep. Right. Okay, so the conjugate of negative 8i is Orlando? 8i. Good, everybody give it up for Orlando. Okay, last one, conjugate of negative 8. Lydia. It's still negative 8 because there is no I. Everybody give it up for Lydia. No,
one more page.
no.
Last page.
Ah.
Last page?
No.
Oh.
It's all right. Let's do this. Okay. So the more I hear you guys talking, what I hear up here is we would really love more examples. So I can actually get out. This is the condensed version of this lesson. I can give you the full Monty if you want. If you want the whole lesson, I can do that. Yeah?
Yeah.
Oh, all right. Jonah is hated now. Okay. Express the reciprocal of 2 minus 7i in standard form. Okay. 2 minus 7i is the same thing as 2 minus 7i over 1. The reciprocal of that, reciprocal fractions, what is a reciprocal? Stacy. Right, you flip it. So the reciprocal of this would be what? So, Stacy, what would the reciprocal be? 1 over? Good. Okay, so everybody give it up for Stacy. Okay. 1 over 2 minus 7i. Now here is where we're doing what Jared was talking about. We can't have any radicals in the denominator. So where is the radical in this denominator? Jared? The 7i. I represents the square root of negative 1. So can somebody, based on our discussion about conjugates, can somebody tell me what they think we might do to get rid of that? Go ahead, Jared.
Multiply it by 2 plus 7i over 2 plus 7i.
Cool. Everybody give it up for Jared. That was the weakest round of applause ever. Okay. So, on the top, we can distribute, or 1 times anything is the thing itself. The bottom, we FOIL. So when we FOIL, we get 4 plus 14i minus 14i minus 49i squared. So you guys can see that this is where the i's cancel out. That goes away, that goes away. What happens to I squared? It changes to what? Negative 1. So then we get 4 plus 49, which is 53. And then the last thing in standard form just means that you want to have one very distinct real term and one very distinct imaginary term. So we're just going to break this up into 2 separate fractions. So 2 over 53 plus 7i over 53. Okay? Questions? Okay. Last one. Now we want to well, tentatively last one. Okay. So we want to express this in standard form. This is exactly the same as the last problem. So what am I multiplying the top and the bottom by here? If in the last one we multiplied by the conjugate, Nathan? Cool, 5 plus I. Everybody give it up for Nathan. Okay, so now on the top and the bottom both we have to FOIL. FOIL, FOIL. So on the top, 3 times 5 is 15. plus 3i minus 35i minus 7i squared. The bottom we get 25 plus 5i minus 5i minus I squared. And then if we go through and combine like terms, they cancel out here. I squared is what again? Negative 1, so we can do that on both the top and the bottom. All right, so on the top, 15 plus 7 is what? 22. 3 minus 35. 3i minus 35, negative 32i. And then on the bottom, 25 plus 1 is?
26.
26.
Wow.
So again, we want to break this up into two very distinct fractions and then reduce if we can. So the first one reduces to what? Good, 11/13. And the second one, 16/13 I. Good. Okay. Questions? Yes?
If I is imaginary, why do we use it?
It's one of those theoretical things. That is a very good question. It's one of those theoretical things. Actually, if you end up going into the field of electrical engineering, they use it in circuits sometimes. Haley?
Is it wrong to put the I next to the 16?
No. No, you can do that too. All right, so there's your homework assignment. Everybody go and get